Hey guys, and welcome to the execute tutorial. We are going to cover all of the subfunctions of execute and go over some tips and tricks on special ways to exploit it and use it to do really cool things. So going into this video, I'm going to assume that you are familiar with how to use selectors. Selectors are a core component of every command ever used. I have a video on selectors that's a little bit old, but it's still valid. There hasn't been any updates to the game for them since. But in essence, a selector is the thing here with the @ symbol, which refers to picking some kind of entity that you're trying to find. So if you do @A, that will select everybody. If you do @P, that will select the nearest player. If you do @E, that will select every entity in the world. And then if you add some filtering like a type, that will select only the villagers in the world. So the first part of execute to cover is execute as. So execute as is going to change who is running the command. The essentials of execute are it allows you to separate who is playing the command and where it is being played. And those two things are able to be modified with a variety of different inputs. And when you put them in certain orders, you can make certain cool things happen. So we're going to go over a simple case where we want to summon a lightning bolt at all these villagers. So if I use as is going to say that all the villagers, @E type equals a villager, is going to summon a lightning bolt. So as I read this out loud logically, what this says is as all these villagers, so go to all the villagers and do something as them and run summon lightning. So here's the thing. It's not going to actually go to them physically. We did not tell it that. So what it's going to do is boom, lightning bolts all on the command block. And that's because we just said make all these villagers run a command and they are going to run the summon lightning command. And that is exactly what it did. So you can kind of read through execute commands logically like that, especially if you're a native English speaker. It should make a lot of sense just reading through it logically what is going to happen. So we're going to go to the next command here. And the next one is @, which is actually going to be what we're trying to do here. So what it does is it moves where the command is being played. And one thing to keep in mind is when you say as, you may be branching off to have multiple commands run at once. So when I said as all villagers, notice how it summoned 4 lightnings, even though the end command is only one statement of summon lightning. It summoned 4 lightning bolts. And likewise, using positional changes like @ and @E, what we can do is we can go to all of the villagers and summon a lightning. So what this does is it will play the lightning command 4 times once at the location of each villager. So when I play this, boom, shocks, exactly what we were hoping to do. So we can kind of combine the as and the @ to get some different relations that do similar or different things. So for example, this is the same outcome, but worded a little differently, but it still makes sense. So it says, as all villagers. So every villager is going to play this command. Go to @S, which is yourself. So for every villager in the world, go to yourself and summon lightning. And this will have the same output. They all get 1 lightning at each other. But if I change this selector to @E type equals villager, you're going to see something very interesting happening. And I want you to just think, what is going to happen when I have as all villagers, go to all villagers, summon lightning? What do you think is going to happen? Just think about that. 3, 2, 1, boom. So yes, it did lightning bolt them, but if you notice, it actually summoned 4 lightning bolts at each villager. So this is something that I would refer to as a logical bug. It's not a bug in the code. The code still works properly, but you just didn't think out that what would happen is for every villager, it will then go to every villager and summon a lightning. So it will go to 1 villager, summon lightning at 4 villagers, go to the next villager, summon lightning at 4 villagers, and so on and so on. So you have to be really careful how you instantiate those things. Now we're going to move on to the next section. So this section is what I refer to as the positional and rotational adjustments. So that previous section was just, diving into it, getting started, changing who and where things are played. This section, we are going to modify where things are played. So based off of a starting location of Stan here, this guy is a villager tagged Stan, we are going to make some changes to what is played. So the first command, and in all these commands, I'm going to be doing either as stan or at stan. And there is only one stan in the world, so it should only pick one entity. And then the following will be the different things that we cover. So the first thing is align. So what align does is it brings you to the 0.0 coordinate of whatever axis you put in. So this says go to every stan and align to the X, Y, and Z axis. What this will do is it will put the marker, or whatever the command following is, it will put it to play in the positive corner where all the axes are 0. And then it will play this crit particle so that we can see what happens. One block up, so it's not inside the ground. And when I run this, it went, and if I hit F3, I can use these 3 lines to line up where the 0 is. So this is the 0 corner, because all the lines kind of lead to it. And that is where the particle is being played, within the current block. So this is very useful for aligning things to your block. And you can just use one axis, which is X, and that will make it align to the 0 x-axis, but still stay in the middle for the z-axis. And you can do just align to z, or xy, or xz, whatever combination you want. So the next one we're going to cover is anchored. So anchored is going to move the location of the particle, or of the starting point of the command, and it will only work if you are as the correct entity and at them. Okay, so anchored looks for who is playing the command and then anchors to their eyes. So if I do as stan anchored eyes, then it will move the command upwards to wherever Stan's eyes are, but still stay wherever the command is. So if I don't have at s, it will just go in the command block and shift the particle up above the command block. So I can kind of show that. But what we're doing is we're anchoring to his eyes, no matter what shape the entity is, whether it's a spider, a cow, a player, whether it's crouched or not. It will go to where the eyes physically are and then do whatever you want there forth. And the most useful thing with anchored eyes is to use the caret notation, which lets you move the command forward, backwards, up, down, left, right based on the rotation, not based on the world. And what this will do is it will play a particle 1 block forward, whatever direction that Stan is facing, to his eyes. So if we go to him, you will see right in his eyes, 1 block forward, he's playing the particle. The next one is facing. This one is a very fun one to experiment with. It will basically turn the command that you want to play later to face whatever you tell it to face. So you can either face a block or an entity, which is the more interesting application. So as Stan, at Stan, we are going to face some entity that is the nearest player's eyes. So it will go to Stan, and keep in mind that for entities, using the at command will move the command to the origin of the entity, the feet, usually, like the bottom middle of the entity, usually the center of the shadow, whatever you want to call it. And then it will face me. So it will go to the bottom here, and it will face my eyes, wherever my eyes are, and then play a particle in that direction. So I'm going to go ahead and play it, and you'll see that if I move around, it's always pointing towards me. If I'm higher, it'll rotate to face towards me. So the next one is position, which honestly is one of the least interesting ones. You have positioned where you can input coordinates, which basically move where the command is being played, up, down, left, right. Sometimes you need it because the later command that you play is not like a particle and doesn't have this ability to adjust where the command is being played physically. So that's where it's kind of useful. Now it also has the as, which is similar to using at. Positioned as is very similar to at, but just knowing that it exists has some interesting implications. So you'll see that this particle is going to be played at me, even though it was originally being played at Stan. Now, where things get a little bit interesting is with the next command, which is going to be rotated. So rotated is a way to separate the rotation of a command from the position of a command. So if I go to Stan, it will copy his position and rotation using the @ command. Now, let's say I want to rotate it a little bit without changing the position. So you can use rotated. Now, rotated has two inputs. It has either hard-coded rotation, like 95 degrees horizontal, 45 degrees vertical. You can do relative, so you can do 180 degrees horizontal, which would make it rotate to face behind Stan. See, it's behind him because he's facing this way, so it rotated 180. So another thing you can do, though, the very interesting one that I love, is as at P. So this is where you can copy another entity's rotation, but keep it in another position. So what this does is you can see that you get interesting behavior. The particle is always kind of like hiding behind Stan because it's rotated as me. So it's trying to copy my direction and put the particle in the one block in the direction I'm facing. And as one final bonus that I don't have a good example for is the execute in command, which will change which dimension your command is running. This is useful if the player enters the nether, but you have a set of commands or things that you want to do only in the overworld, because the nether has different distances and blocks, so certain things might break. So maybe something only works in the overworld. You can force it to only do it in the overworld using the in extension. Now let's move on to the different ways that you can modify who is playing the command. So this section is probably the most diverse in terms of overlapping with other command features such as scoreboards, data, and all those kind of things, but I'll try to go over it very briefly here. So next is the if modifier. So the if and unless, they kind of go hand in hand, just opposites, basically are like gates, which prevent you from going forward if the condition is or isn't met. So we could do something as all the villagers, but then have a condition with if that prevents certain villagers from being picked, which usually you can do that inside the selector, but some tests you can't do in a selector, such as with blocks. So what this is going to do is if the block in the center is a grass block, say passed. So I click it, it says passed, but if I break the grass block, now it doesn't say passed. Very simple. Now we're going to go to a more complicated case. We have execute if blocks plural. So this is going to test if the blocks that are in here and here match the blocks that are here and here. The first set of chords is going to be kind of your bounding box corners. So you have to pick two corners of your region that you're testing, that you're going to test against. And then the last set will be the bottom positive corner. So you have to find the bottom positive corner that matches what you are trying to test. And it will assume based on the size of the first two inputs, what the size of the second one is or where the fourth point is supposed to be. So in this case, we picked this block here. And since we picked two blocks in the beginning, it will assume that the region that we're testing is this one and this one. So when we press it, it'll say same because they're the same. But if I break one block, then it will not say same because they are different. However, since I add the masked modifier, if I break this one, it'll still say same because this block is air, and with masked, any air in the input region you're testing is allowed to be anything in the output region. That's just a little extra tip there. So the next one is if data. So you can test the data of things. There is a very huge field of detecting data and playing around with data. But in general, blocks and entities have MBT data. If I do /data get block, this block, it will tell me what MBT data is associated, as well as things like the items inside it being a chest in slot 0, just like this. So this if data can look for a path, and paths are defined in a special way, which you can find other tutorials on. But essentially, if there is an items array, say it has items. So if I click this, it has items. But if I take this out, I run the data get, you'll see that there is no more MBT data. Like the items is empty. The items array has empty brackets. So I can test, let's see, if you have items at 0. Okay, so if there is any items in the thing at all, then it will not pass. But if there is something in there, it will pass. So then the last sets are if entity. So if entity lets you do additional checks for entities, which usually you can fit into a selector, but sometimes you can't. So this one will say if anybody is within 2 blocks of the command block, say near me. So if I click this, it will not say near me, but if I get close and click it, it will say near me. Just works as you would expect. If anything passes that criteria, let it on through. Next, we have scoreboards. So you can basically say if your score, so scoreboard players set at S, test 1, 2. So my score is 2. So if 2 is greater than or equal, if test 1 matches 1 with 2 dots, which mean including and up to infinity, positive infinity, then that means that it will pass the test. So if I click this, it will say greater than 1. My score is greater than 1. This next test would say 2 dots to the bottom, including 1. So if it is less than or equal to 1. So that would include any negative numbers. So if I set it to 0, then it will say that my score is less than 1. And you can do all kinds of tests here. So you can test if that score is equal to some other player's score. So the last most complicated section, arguably, is the section on store, which again combines with other commands in many different ways. So first we have execute store result, and we'll go through store results block first because that's the simplest. So what this will do is it will store whatever the output of the command after the statement run is, and then whatever number that returns will go onto the count of the 0th item in the items inside the chest. And it will specify that that count has to be a byte value. When you do store, you have to specify a lot of times what kind of data value it is. If you get the wrong one, the output will be weird, like zeros and stuff like that. So you have to make sure it's the right data type, and count is a byte data type. So then I just run if entity at E. So if entity, this is kind of an interesting application. So when I run this command, it doesn't actually have a run at the end, but when I run it, it says the words, it'll say how many entities there are in the chat. So if you read this here, it says test passed, count 61. That means when it was last run, it found 61 entities. So I can go into this block, I can put a sand in it, and I can press this button and it'll make the count 60 because it's found 60 entities. But if I go ahead and drop a spruce planks and click it, now it will say 61 and it'll store 61 onto the count. The next one is to store a score. So it's the same thing, if entities, but now it's storing it in the score. And let me change this to at P. And now we're going to have 60 for our score, but we drop this and we have 61 for our score. So basically, it returns any number that could have been stated from your command. A lot of commands do output a number, so go ahead and test them. Some little interesting applications are with clear. So I can do this, and I can run, instead of if, I can do run clear at S spruce planks, and it'll make my score whatever the spruce planks that it's able to clear from me. If I put a 0, it won't clear any, but it will still state how many I have. So if you see in the chat, it says found 64 matching items on CloudWolf, and my score in the right side is now 64, but that's pretty advanced. So just as a bonus, I'm going to run through a couple really interesting applications of the execute command, 3 that I particularly have made separate videos on that I will link in the description for you to check out for a better description of what they do. But very magical things can happen when you combine lots of different features of the execute command together. So the first special application is using the store result command. So if you store a number somewhere and it is a negative number, and you then scale that number by some value very close to the edge, because the store result command is going to typically, if you have a byte or an integer, it's going to floor it. You can use that to increment a number with just one command. So you can see this in play. We have 32 stone in this chest. It will grab whatever number is on the stone, multiply it by negative 1.00001, and then it will multiply it by negative 1 again, but store it as a byte, so it will floor that to become the next number. So if we click that, it's 33, 34, 35. And I guess more simply to understand, if we take the number and we multiply it by 0.9999999, then it will scale it and floor it to be 1 less. So it will go 35 to 34 to 33 to 32 to 31. And that's kind of an interesting mathematical thing you can do with it. Another cool one is to combine a lot of these different things as, at, anchored, to use some geometry, to exploit some geometry with these selectors to basically create new selection regions that are special geometries using the properties of vectors. And this is very complicated stuff. You're going to have to go into the description to understand why it works. But essentially, if I look near the villager, it'll glow him. So if I'm looking away, nothing. But if I look near him, it makes him glow. And this is really cool because it works with FOV. So if I'm really close, he will detect a little bit sooner. And it's very powerful, but you have to use a lot of geometry to make it work properly. But it's basically what I refer to as a conic selection region. Now, the final is to use even more advanced vectors in mathematics, and you can use execute commands run on repeat to perform iterative processes. And I described this in one of my other videos on how this exactly works, but it uses a combination of vector-based math and some trigonometry and geometry to teleport the player's facing direction towards a direction, but only in a certain step, having it each time. So if I'm looking this way and I want to look that way, it will teleport me to 45 degrees, then somewhere 22.5 degrees, and then smaller and smaller and smaller. But when you do that 20 times a second, it becomes a smooth camera rotation. So no matter where I look, it will make me face the front, just like that, using just one execute command and various trigonometric and geometric identities. So just like that, very simple, very powerful. Anyways, guys, that's it for this tutorial. It took me a lot of work to organize it. Hopefully the editing is decent, and there's some interesting content for all kinds of people that are experts, beginners, intermediates. And if you have more questions, leave them in the comment section below. I'll try to answer as many questions as I can. And if you want to stick around, maybe subscribe, let me know what tutorials you want to see next. I don't have too many things planned, but I can always make room for a good idea. Thanks for watching, and I see you guys next time. Peace.